Hello people, today we're going to talk about logarithmic functions, just the very basics. The definition for a logarithmic function is for any x bigger than 0 and b greater than 0 as long as b is not 1. Y equals the log base b of x is the same thing as saying b to the y equals x. And this would be considered in logarithmic form, and then this would be in exponential form. Logarithms are the inverse of the exponential functions. So I wrote the inverse function of an exponential function with base b is the logarithmic function with base b. They're inverses. They undo each other. Look down here. I've got the log base b of b to the x is x, because the log of this exponent cancels out, right? I got a little sketch of the graph, and we'll talk more about the graphs of logs later. And here's a sketch of just a generic exponential function and the logarithmic function. Now remember, to graph the inverse of a function, you reflect it over the graph of y equals x. And I'm just going to real quick, here is y equals x. So it's like you take it and you flip it. They're inverses. Hey! All right. So what we're going to focus on is this part of the definition, and we're going to convert from one form to the other. Okay, so let's do that. All right, so for the first one, we got 4 equals the log base 2 of x. So that would be in this form, and we want to change it to this form. So see, the base of the log is the base of this x, exponent power here. So 2 is the base. So this would be 2 is the base. All right. This part, the 4, see here, y is your exponent. So 4 would be my exponent equals, and this is what it equals. Okay? Not too bad, right? Let's try another one. So we have the log base 3 of 9 equals x. So my base goes here. 3 to the, this is going to be your exponent. X equals 9. All right, and one more. Log base 4 of 7 equals y. So the base goes here. What's my exponent going to be? Y. And that will equal 7. Now, let's do that backwards. We're going to write these that are in exponential form and logarithmic form. So we got b to the 4 equals 16. So remember, this is going to be the base of my log. So log base b. And what are we taking the log of? Well, 16. And that will equal my exponent, which is 4. All right, let's do another one. So this one's written the reverse of this one, see? So if you want to rewrite it, 5 squared equals x. That makes it easier for you. That's cool with me. So the log, what's the base going to be? Base 5 of x equals 2. All right, one more. The log base y of 8 equals 3. And you're just using this definition to go from one form to the other. Okay? All right, now what we're going to do now is use what we know about how to change those to actually evaluate some of these logs. So we have the log base 3 of 81. Well, we know because of the definition that that's the same thing as saying 3 to the what equals 81. So 3 raised to what power equals 81? And that would be 4. All right, let's try another one. We have log base 36 of 6. So that's the same thing as saying 36 raised to the what? I'm going to use a variable this time. equals 6. So what's the relationship between 36 and 6? I mean, 36 squared, you know, that's some huge number. That's not gonna, I'm obviously gonna have what kind of number? It's going to be a fraction. I know that the square root of 36 equals 6, right? I also know that the square root of something is the same thing as raising it to the 1/2 power. So 36 to the 1/2 equals 6. Okay? Just like another example of this would be the cube root of x is the same thing as x to the 1/3, right? That's just a little side note. All right, let's look at the next one. Get back on track. The log base 5 of 1. So that's like saying 5 raised to the what power equals 1. And we know that anything raised to this power equals 1, and that would be 0. All right, for the next one, the log base 2 of 16 is the same thing as saying 2 to the what power equals 16, and that would be 4. Because 2 times 2 times 2 times 2 is 16. All right, 16. Let's try another one. The log base 7 of 1 over 49. Now, that's like saying 7 to the what is 1/49. And you may want to think of 1 over 49 as 1 over 7 squared. And what do we know about the exponent on bottom? I can move it up to the top, right? But what would happen to that 2? It would become negative. So x would equal -2. 7 to the -2 is 1 over 49. Whoops. All right. Now, I want to go over some basic log properties. There's more than this, but these are the basics. So I numbered them because we're going to refer to them when we do this example. So the first one is log base b of b equals 1. Well, again, it's like saying b to the what equals b. 1. Anything raised to the first power is itself, right? The log base b of 1 equals 0. Now, these b's could be anything. This could be the log base 6 of 1, the log base x of 1. Anything raised to the 0 equals 1. The log base b of b to the x. So that's like saying b to the what is equal to b to the x. Well, x, b to the x is equal to b to the x. So that's why that equals x. And then this is just using the fact they're inverses. You've got this exponent and then this log. They cancel each other out and you got x. Okay, so this may seem complicated, but we're going to apply it and it is really simple. Let's look at the first one. So we have the log base 8 of 8. That will equal what? 1. And that's using this very first property. Log base b of b. 8 of 8. So the answer is 1. All right, let's look at the second one. The log base 7 of 7 squared. That is going to equal 2. And that would be using the third property. See, the log base b of b to the x. The log base 7 of 7 to the 2. 2. All right, the log base 6 of 1. We already said everything raised to what power equals 1? 0. All right, how about this one? 5 to the log base 5 of 8. We know these are inverses. They undo each other, so it's going to equal 8. That's using this fourth property. And again, we have 3 raised to the log base 3 of 15. Those are going to cancel each other out. We'll get 15. We're using the fourth property. All right, let's look at number 6. The log base 2 of 2 to the third will equal 3. And that would be using the third property. 2 to the what is equal to 2 to the 3? 3. 2 to the 3 equals 2 to the 3. The log base 9 of 9. 9 to the what equals 9? 1. And that would be using the first property. Whoop, 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 whoop. The first property. All right, this one's a little tricky. The log base 3 of 1/3. And I could rewrite that, if I wanted to, as the log base 3 of 3 raised to the what power? Why did that 3 end up on bottom? Because it had an exponent of -1. So the log base 3 of 3 to the -1 would be -1. All right, that's it for today. Have a wonderful day.